Okay, so now we are down to the next section, which is balancing chemical equation. So the key idea here is actually about the conservation of mass. Now, what does balancing chemical equation is to make sure that the atoms of each element, okay, before the reaction is equal to the atoms of each element action. Now, what do I mean by that? Okay, so let's take a closer look into some of the equations here. So the first equation I'll look at is actually a very, very common equation that we used to always start with. Okay, and let me open up my document. Okay, so the first one would be N2 nitrogen plus hydrogen, giving me this compound called ammonia. Okay, normally to balance the equation, we will write a number in front of each of the substances. Okay, so now where do I which is before anything that's before this line over here, okay, that I draw on the arrow, this is actually before reaction. Anything after this line over here, of course, would be after reaction. So if you want to interpret this chemical equation, it's sort of like saying nitrogen reacts with hydrogen, and the product formed is NH3. So before reactions, this is what we call reagents or reactants, or things that react together. After the reaction, this is what we call the products. So now, let's start our balancing. So let me use a red color to indicate. So before we start balancing, let's count the number of atoms of each element that we have. So for here, N2 means that we actually have 2 nitrogens. So all of the same element we write in one row. Okay, so 2 nitrogens over here. Here we have 2 hydrogens. So you can see because it's a different element, I'll write on a separate row. Okay, here we have 1 nitrogen, 3 hydrogens. So this is sort of like indicating how many atoms of each element that we have. So once we have done so, what we're going to do next is to balance it. So how do we exactly balance it? So what we're going to do now is to compare before and after. So let's start with the first one. So look at the first row, we have 2 nitrogens over here, 1 nitrogen over here. So how do we make them both equal? Do take note. Okay, what we're going to do here is that we're going to put a big 2 in front of it. What does this big 2 in front means? Means that we're going to have 2 times of ammonia. So 2 times of this means that I'll multiply 2 here, multiply 2 here. So what we're going to have is 2 nitrogens and 6 hydrogens. So let's look at this nitrogen over here. Left hand side we have 2, right hand side we have 2. So we are done balancing. Once we have balanced nitrogen, let's go on to the next element, hydrogen. So we've got 2 hydrogens over on the left hand side, 6 hydrogens on the right hand side. So what do we do next? We put a 3 over here, because by doing so, 3 times 2, we got 6 hydrogens. So both left and right for nitrogen, left and right for hydrogens are balanced. So what did I do over here? So actually one of the first things that I did to let you know was actually to balance one element at a time. Mostly confused in balancing chemical equation because they balance too many of them at a time. Okay, so the first rule when it comes to balancing chemical equation is actually to make sure that you only balance one element at a time. Okay, now let's go on to another example. Another example, what do I have here? Let's try another simple one. Okay, let me change my pen color to black. Okay, so what I'm going to have is CaO, calcium oxide, undergoing thermal decomposition to give me calcium and oxygen. Okay, so I'm going to have the line over here to show the balancing. So looking at here, okay, time to break down everything. Okay, time to break down everything. Here I have 1 calcium, 1 oxygen. The line over here. On the right hand side, the product, I have 1 calcium, 2 oxygen. Okay, so if I go row by row, first one I see calcium. Left hand side I have 1, right hand side I have 1. So calcium is balanced for now. Oxygen, left hand side I have 1, right hand side I have 2. So what do I need to do here? I need to put a big number 2 in front of it. So when I put a big number 2 here, what you realize is that I will actually, sorry, let me change my pen color. By putting a big 2 in front of here, what I'm doing is multiplying calcium by 2, multiplying oxygen by 2. So 2 calciums, 2 oxygen. So oxygen now, okay, good, balanced. 2 oxygen here, 2 oxygen. But what you realize by putting a 2 here, you have disrupted calcium. Okay, initially calcium we said was balanced, 1:1. Now there's 2 calcium on the left hand side, 1 calcium on the right hand side. So what do we need to do here? We need to put a big 2 in front of here. So we multiply the calcium on the right hand side by 2. You have 2 calcium. So what you realize before and after, they are now balanced. So the second point I'd like to highlight is this, is that this is really a trial and error method. When you're balancing chemical equation, okay, initially it's really seemingly like a trial and error method. You're doing one element at a time. When you do one, you may disrupt the other. So it's important to make sure that you persevere all the way. Do not get too confused. Okay, because once you balance one element at a time, eventually you reach the end point, which is to have a balanced chemical equation. I'm going to go on to a third example now. Okay, so this third example is to illustrate my last point I'd like to make. So the next equation I'd like to put across would actually be C. Sorry, let me erase this. I got C3H5 plus Cl2, giving me carbon plus hydrogen chloride. So draw the line over here. Okay, have the line over here to make sure that you know where you're going to write to balance your chemical equation. Okay, now let's use a different pen color to indicate how many atoms of each element do I have. So first row, let's dedicate it to carbon. So 3 carbons here, 1 carbon here. 5 hydrogens here, 1 hydrogen here. 2 chlorine here, 1 chlorine here. Okay, so all of the elements, the atoms of each of the elements, I've actually written it out. So now it's time to start balancing. First row, 3 carbons, 1 carbon. So put a 3 over here, multiply by 3 carbons. Next one, 5 hydrogens on the left hand side, 1 hydrogens on the right hand side. So I put a 5 over here. In doing so, I also multiply by chlorine. So I have got 5 chlorine on the right hand side. Now, what you realize is this. I have 2 chlorines on this side, 5 chlorines on this side. I can't multiply by a whole number. But what I can do is, if I multiply this by 5/2, you're going to get 5 chlorine. So this is the part where many people say, "Sure, you mean you can write fraction for your balancing chemical equation?" So typically whenever you're balancing equation, we will not have fractions over here. What we will need to do at this step, because firstly, let's double check first. First row carbon, 3 on the left, 3 on the right, balanced. 5 hydrogens on the left, 5 hydrogens on the right, balanced. 5 chlorine on the left, 5 chlorine on the right, so it's also balanced. So actually my chemical equation here is balanced. Just that you cannot, okay, most of the time we will not write down fractions while balancing chemical equation. So what do we need to do here? So you realize that the denominator here we have is 2. So what we'll do is we'll multiply the whole equation here by 2. So multiply by 2. So what we're going to get is 2 over here. Multiply by 2, we got 5 over here. Multiply by 2, we have 6 over here. Multiply by 2, we have 10 over here. So actually my balanced chemical equation Okay, let me scroll down. I'm going to rewrite this. It's actually 2C3H5 plus 5Cl2, giving me 6 carbons and 10 hydrogen chlorides. Okay, so this is how you go about balancing the chemical equation. So do take note. Okay, the last point I'd like to make is actually this. Okay, it is that we can use functions to balance chemical equation as an intermediate step. Okay, I use the word intermediate step. Okay, so but at the end, to make sure that the whole thing is done up properly, you must multiply it by the denominator of your fraction. Okay, so this is for the chemical formula, balancing chemical equations. So do take note, it's important to know the key concept, which is it's all about the conservation of mass. Atoms of each element before the reaction must be equal to the atoms of each element after the reaction. That's all.